The question 18 is basically composition of functions. Here we have to add them, subtract or multiply or divide the functions. You will be given f of x and g of x. You need to find f plus g of x. What does this actually mean? Now here you can see it is f plus g of x. Which is the first function here? It's f of x, right? F. So it basically is f of x plus g of x itself. That's it. Now if you see this f of x minus g of x. Why it's very important the positions? Because imagine you're subtracting. If you do g of x minus f of x, the answer is different, and f of x minus g of x, the answer is different. So please see which is the first and the second functions. Now let's solve this up. For adding, it's very simple. You should just add them up. Function f of x. See, now in writing exam, what you need to do is write this. It'll be f of x plus g of x, and then substitute what is f of x. It's 2x plus minus 4x plus 5. Here it'll be 2x minus 4x plus 5, and we will get 2x plus 5. If it is subtraction, it'll be same thing, but it's only minus over here. It'll be 2x minus 4x plus 5, and we will have 2x plus 4x minus 5 this time, and you can see it'll be 6x minus 5. Adding, subtracting is very simple and straightforward. What about division, sorry, multiplication? It's again the same thing. F of x multiplied by g of x, and now over here we have 2x multiplied by minus 4x plus 5. If you have thought, what if we write g of x times f of x, the answer will be same, but in a writing exam, make sure you write this. It's always the first function multiplied by the second function. So here 2x is multiplied, and it will be minus 8x squared. This multiplied here and here, distributed. So it will be minus 8x squared plus 10x, and this is the answer. Now the last one is division. What does that mean is it's f of x divided by g of x. And we know f of x is 2x and it is minus 4x plus 5. What do we do here? This is it. We don't do long division or anything. We stop here. But there is a very important thing. Can you have any denominator of 0? When you make denominator close to 0, it becomes a huge number. Just do say 2 divided by 0.00001, which is very close to 0, right? You will have a huge answer. That means as you go towards 0, it's infinity. So it's undefined. You can't make this 0. So what we do is we will avoid it. We know minus 4x plus 5 cannot be equal to 0. If it is equal to 0, this is undefined. So let's solve for x now. Let's take the negative to the other side. It cannot be equal to 4x, and 5 by 4 cannot be equal to x. So basically we know that this can be the answer, yes, but x cannot be equal to 5 by 4, because if you put 5 by 4 here, what happens? It becomes 0. It will be negative 5 plus 5, it's 0. So therefore we avoid that. So that is how we solve it up. So you can see it is minus 2x plus 5, 6x minus 5. We got minus 8x squared plus 10x. And lastly, we got the same answer. Now here, instead of writing down, you can write it out over here, the negative sign, that's fine. But not equal to 5 by 4 is very crucial. So this is how we solve these problems. And they are all the same. Please do solve them by yourselves. You can see the detailed solution for each of these problems. So again, we have got a similar problem, just that when you write this, it's fine, but write this, it's not equal to what? And how do you do it? Just make 2x minus 7 not equal to 0. You can't have the 0, right? And then 7 to the other side, 2 divided by, it'll be positive 7 by 2. Even over here, it's the same thing. Now over here, since it's squared, when you multiply it, you will get cube. Okay. And okay, now this one, again, not a big problem, just same thing, distributive property. Adding, subtracting is very simple. Here, what you can do is, instead of both the terms together, do this. And then this distributed for method. So it will be 2x squared times minus x squared will be minus 2x to the power 4. Again, x squared will be minus 3x cubed minus 5x squared. And then over here multiplied by 6. 6 times 2 is 12. Then 318 to 30. And write the variables. That's how we do it. But what happens over here? Don't worry, it's the same thing. But we have to make it not equal to 0. But there's a problem. It's a quadratic. So you can just put this in the calculator because there are two answers now. Let's take our calculators. Here you need to see it's quadratic, right? So mod, this is an equation phi, and quadratic is given by option 3. Mod phi 3 gives you that. Or if you have a higher version of calculator, it's mod alpha and a over here. That time you'll get it polynomial simultaneous. Go to polynomial, select degree, and you'll get over here. The degree over here is 2. So now, first term, a is whatever is the coefficient beside x squared. It's 2. Then we have 3, and lastly we have minus 5. So remember, the order is x squared, x, and the constant, no x at all. So it's first 2, 3, and minus 5. And the answers are 1 and minus 5 by 2. So x cannot be equal to 1 and x cannot be equal to minus 5 by 2. Or means these two are not included in the solution. So this is how we basically solve them up. And here again, it's another similar problem. Please do go through it by yourselves. Here also, go to mod phi 3. You're supposed to get two answers. That is 4 plus 2 root 3 and 4 minus 2 root 3. Let me just show you in the calculator. Again, mod phi and 3 over here. And type this out. The coefficient, nothing means that's a 1. Then we have minus 8. And lastly, we have 4. The answer is 4 plus 2 root 3. Don't write it in decimal. It will generally be in a fraction form like this. And then, okay, over here it is 4 minus 2 root 3. These are the two values to be avoided. They have written plus or minus because both are included over there. Now we have a real world problem. You can try these by yourselves before I start solving it. You can read them. You can pause the video now, read them, and try solving it. Here, Trevon opens a checking account that he uses only to pay fixed bills, which are expenses that are the same each month, such as car loans or rent. The checking account has an initial balance of $1,750 and Trevon deposits $925 each month. The balance of that account can be modeled by A of x, that is 175, that is 1750 plus 925x. Now, to write this equation, it will be given, but let's understand what it is. This is the amount which is already fixed. He has initial balance. It does not change. That is over here already there. But every month he's going to deposit how much? 925, right? So x means after 3 months, all you need to do is if you put x of 3 and you solve this, you will get the amount of money he has after 3 months. That will be 925. 3 months is deposited. So if it's 1 month, just put 1 and so on. So that is how we get this equation, where x is the number of months since the account was open. The total of Trevon's fixed bills are modeled to be 940x. Now here, how much is depositing? 925 every month. But his bills, say his rents and loans and everything, is 840 every month. So over here, this is the difference. So he's putting more, that's fine. 60 is 85, the $85 more is depositing, that's well and good. But here, this is the equation given. X means for every month. Define the graph of the function that represents the account balance after he pays. Now first, let's write over here the first A1, identify and write a new function that represents the account balance. So whatever money has put, some money is deducted as well, right? What is exactly happening? Over here, to understand how much money is left in that account balance, we have to do A of x, what he has, minus the bills, that is B of x, bills are removed. So this is the function. So it is a minus b the whole of x. You can write it like this as well. Composition of functions. And now your first one is 1750 plus 925x minus 840x. So it is 1750 plus, it was 85x. So this is the given function. So that is the part A, combined account balance. You can see it is, okay, you can write 85x first, that's fine. And this is the answer. Now, what about the other one, graph? You should just graph this out. You can use the table method or whichever method is possible. Here, let me just tell you about the graph. Now, what we got over here was 1750. There is no x. That is the intercept. So initially there was so much money. There it will start the graph. Now this 85x is what's happening. The graph is, it's positive, right? The slope is upwards, positive, and here if you take a slope, then you will get 85, positive 85. Now basically your positive 85, that's the slope throughout the function. How would you do it is, you can choose, say over here, you know the intercept, and after phi, that means after phi slopes, so it is, how much was that equation, 1750, over here there was 85x, right? Put over here x as phi, whatever answer you get must be plotted over here, and then draw a straight line. But I will tell you how to do the table method, which is very easy. You'll get a lot of points in that, but you need a calculator for that. You need to go to mode, and then you need to press the table option 7, and over here we get the function. Now what is the function? It was 85x plus 1750. You can even write 1750 plus 85x, the answer will be same. You may not get this option, but if you get this option, just ignore it. We are just graphing one equation. And now where do you want to start? So the start and stop is basically the x values. So now see, it's about months. I will have to start at 0 or 1. I'll start at 0. And let me end it at, say, I don't want all the months, just a graph of like 5 to 10 months is enough. I'll take about 8. And what is the step? Step means, see, I took 1 to 8, right? How do you want? Every month do you want means 1. So it'll give me 0, 1, 2, 3. If I put 2, then it'll jump to 0, 2, 4, 6. You can jump as well, but let me take over here for now step as 1. And I get the value C. At 0, it must be 1750. Okay. At 1 over here, it should be 1835. Let's see. 1835. Yes, it corresponds somewhat there. 1920 at 3, yes, and then we have at 3 as 20. It's very close to 2100, means it's 2000, and then over here it's 2090, so it's almost close to 2100, and you can see the other values. That's how we plot them from here. Now this scale is very important. Now what I would do is, generally, because we have a jump of 1750, 300 is reasonable scale. I would have gone with 250 because it's much clearer, 250. Or here they have taken 300. Yeah, it's fine, Even you can go with 500, but you need to make lot of, see, lots of values will be very close to each other when you plot, because if it's 500. So better to go with 250 or something reasonable. And over here, it's the same thing, I believe. Yeah, the total cost. So you just basically subtract them, sorry, add them over here. Why? Because they have told t-shirt and game jerseys, the coach t-shirt has so much cost. Okay, and over here there is another cost. This is another cost, the online ones. You add them up. If you read the problem, you'll understand there are two costs. Now imagine you're buying something from a store, buying something online. What is the total cost? Add them up, right? So you add them up and you get this answer. And now you graph it just like we did it. So the intercept is 55 and there is 25.5 depending on the number of people, team members. Now we have the scale you can keep as 0 to 10, and you can give the jump of 1 only. And over here, take a reasonable scale. 50, 100 is much better because it's at 55 over here. Now this is another type of problems. Let's look into this. The National Center for Education Statistics report data showing that since 2006, college enrollment for men in thousands can be modeled by this function here, where X represents the number of years since 2006. Similarly, enrollment for women can be modeled over here. Write a function f of x plus g of x and interpret what it says. So now they have just told us to add these two functions. Okay, let's add them up. You have to just add 280 plus 389, 750 plus 10,075. So this is it. Now they want to know what it says. That means it's the total enrollment. Now, every year, from 2006, there is an increase in the student, male and female, by 869. And at the 2006, there was already 17,575 students. The function represents, and okay, they have just told that much only, but you can tell more. Basically, what is this x means every year that is changing. This is the intercept. Already there were there so many students were there, and then next year it's becoming more and more. So basically both men and women. And now over here we have a table, and we have been told to solve these functions. This is also again an easy one. So now you have not x or y, it is in terms of -1. What does this mean? This basically means f of -1 plus g of -1, isn't it? What is f of -1? We have the function of x over here, and -1, 0, 1. So what is f of -1 exactly? It's 7. What is g of -1? It's -3. So 7 minus 3 will be 4. So that is the answer. Here you have h of 0 minus g of 0. So what is h of 0? It's 4 minus of -4. So it will be minus and minus will be plus. It will be 8 as the answer. Now we have multiplication over here. F of 4 times h of 4. F of 4 is 1 times h of 4 is 5. The answer will be 5. And division, let's do this one. G of 1, where is it? It is -5. I've written directly above, it should be g of 1 divided by f of 1. Okay, -5, what is f of 1? 0 multiplied by 0. So the answer is 0. You can do the others by yourselves. So it's 4, 8 minus 5. This is pretty straightforward. It's 4 divided by 1. 0 divided by 1 is how much? Oh, sorry, I have done a mistake in the last one. It is 5 minus 5 divided by 0. Okay, so it is basically g of 1. Let me write it properly. And f of 1, isn't it? It is g of 1 minus 5 divided by 0. This is undefined. It cannot be. It's wrong, because the answer will be towards infinity. It can be anything. It's undefined here. So you can put -5 divided by 0. You get math error in your calculator because it's undefined. But you can divide anything by 0. So 0 divided by any number is 0 itself. Okay, so this is fine if 0 is in the numerator, but it cannot be in the down part, denominator, not allowed. So that's how we solve those. And here they have asked you f of, okay, find these terms. Okay, this is interesting. Why? Because they have given us the answers and told us to find the functions. So f of 3 plus g of 3 is equal to 5 is known in the first equation. And what is known over here? F of 3 times g of 3 is equal to 6. Okay, so we need to find these two functions, isn't it? Now I can get one function as another. Generally such problems are written as a, b or x, y and solved. So let us take f as x and y, g as y. Okay, it'll be easier. X plus y is equal to 5. Here x times y is equal to 6. Now let me take this y to the other side. It will be x is equal to 5 minus y minus. Here we know it is x multiplied by y is 6, right? What I'll do is, instead of x, I'll substitute this 5 minus y into y is equal to 6. Now I got everything in one variable. Let me multiply. 5y minus y squared is equal to 6. Let me bring it all inside. It will be minus y squared plus 5y is equal minus 6. Sorry, minus 6 is equal to 0. You can leave it like this or change the sign. It's fine. Now to find the y value, you should use your calculator. All you do is mod and 5 and 3. And the coefficients are -1, 5 and -6. The answer is 3 and 2. So now this over your y value can be two possibilities, right? So let's write it. Y is equal to 3 and y is equal to 2. So let's solve x for both the cases. If at y is equal to 3, x is equal to 5 minus 3, that is what? It's going to be 2. At y is equal to 2, x will be equal to 5 minus 2, that is 3. So the answers over here will be a f of 3 is equal to, you can x value is equal to 2, that time g of 3 is equal to 3, and f of 3 is equal to 3 when g of 3 is equal to 2. So these are the two possible solutions. I hope this is clear. And one quick thing, if you want to go out of this mode, I hope you know you can either clear your calculator or press mode and 1, computation mode. You'll be back to computing mode. Now, these are the answers. You can see here the solutions. Two solutions are f of 3 is equal to 2 and g of 3 is equal to 3, and over here f of 3 is 3 and g of 3 is 2. So that's how we solve this problem. You just can write what I have written over here like this. I've taken x and y, that's fine. They have taken over here a and b, that's also absolutely correct. Now we have an interesting problem here. They have told write two functions f of x and g of x, like two functions. Now I will take a random function, say for example x plus 2, and over here I'll just take x minus 2. Okay, I'm not sure whether this will satisfy this, but anyways, we need to find the composition. Remember, this is not multiplication. F of say f whole g, this is f composed g, is not same as this one. Till now we saw the dot. This is what? F of g of x. It's composed within each other. There must be x and x over here. Now here this is just multiplication. So you multiply them both, and composing them and multiplying is two different things. So please be careful with this. So what happens here is, now 4 I will add it at the end. Okay, let's do that at the end. Now for now, how we compose it is f of g of x, two brackets to close, f of, instead of x what we have is g of x. So what is g of x? Goes instead of x here. So I don't write x, I write x minus 2, and then what is remaining is plus 2. This is how we do composition. And now let's solve it up. It will be x minus 2 plus 2 is 0, so it's x. Now this is g of x, okay? But we need a 4, right? Composed of 4. So you can either write this or you can write it like this. Both are same thing, okay? So I'll write this given function g composed of 4. The answer is 4 now. Sadly, this doesn't satisfy. We have to make it 0. So now you need to find a relation. If I take, you can assume one thing, whatever you want, f of x. What must be the other thing? So here, if I have to get this 0, what should I have been over here? If you, like, see from the answer, you can go back. There must be minus 4, right? There must have been a minus 4 over here. Then I will substitute x as 4, it becomes 4 minus 4 as 0. If this should be minus 4, what should be over here? Like here or over here? It's up to you. Now since g of x is substituted, what I'll do is I'll change this. It's much easier, right? If this has to be minus 4, I have to add minus 4 here. So what happens if this is minus 4, it will be plus 2, it will be minus 2. So if at all I add this as minus 2, what's going to happen now? Let me take it. 4 plus 4, it will be minus 2. See, just solve this up. If it's minus 2, yes. So don't worry about this function, leave it, only these two. See, plus 2 minus 4 is minus 2. And now let's solve them up. If I have x minus 2 here, I'll erase this all. Wait, it's minus 2. Now can you solve it up? It's going to be minus 2 minus 2. What happens? It'll be x minus 4. Now substitute 4, it will be 4 minus 4. That is 0. So if you have two same functions, yes. But now what if they don't allow for same functions? If they have mentioned, this is possible, okay? If you have two same functions and you composed, you will get, when you substitute 4 over here, you'll get 0. But what if they don't allow you two same functions? You need to have something else. Now we will just change the value of f of x. Now what I would suggest is take a bigger value of 4. Okay, I will take f of x, say plus, or you can take minus, then the other one will be plus. I will just take this as 8, plus 8. So what happens is this g of x must have a difference of 4. Now I will tell you why. Because imagine it is anything, the g of x is anything. When you compose it, this is g of x, it'll be this term, right? It's plus 8, and this term becomes x some number. What is the number I should have over here? We just now saw, right? It had to be difference of 4, right? This finally it should be minus 4. So over here, if you have, say, minus 12, 4 more than 4, but negative sign. See, it should be x, 4, add 4 to 8, it will be 12, but the sign must be minus. Why? Because we need negative 4 right at the end. Now what happens is, it will be x minus 12 plus 8, that is x minus 4. Now you substitute over here g of 4. When you substitute, it will become 4 minus 4. The answer is 0. It is satisfied. Now, why I did this is, see, the first one is also correct, but that was same numbers. If they ask you specify, take those two separate numbers, then these are the answers. You can even change this, say, over here you can make it 5, and this will be minus 9, it will work. Just make sure there is a difference of 4. If this is, say, I can even take like this. We will take addition of one term, say 1. Then add 4, it will be 5, right? But it should be minus. This is it. That's the relation. And let's see over here what they have done. See, over here they have taken minus over here, minus 9. But now there must be opposite sign. See, if this is minus, the difference must be how much? Minus 4. How will you get it? If you add 5, right? You can't subtract. That time I had taken positive first, so I was telling difference of minus 4. Basically, when you add these two numbers, you must get minus 4. Another way to understand is you can assume anything over here. If you take, say, x minus 9, this will be unknown. What is it? Minus 9 plus unknown value, say, block must be minus 4. That's it. Because over here it's plus 4, it will be 4 minus 4. That's the answer. So what is it? It should be 5. Minus 9 plus 5 is plus 4. You can put this in the calculator and get that value. So I hope this is clear. It's a simple one. We're going to the end. Over here they have told Chris and Tobias are finding composition of the functions where they have given these values. Who is correct? Let's see both of them. Let me do it first properly, okay? So f of g of x, what happens is, now this function goes inside x. Wherever x is there, it must be put over here. So instead of x square, I will have to write x square plus 8 plus 2 times. Instead of x, I write x square plus 8 minus 8. Now we solve it up. Okay, this is gonna be a big one. See, now since we are not going to solve it, it's fine. But we are just correcting, so it's fine. But otherwise, how you solve it is a plus b the whole square formula. It is a squared plus 2ab plus b squared. We have to apply this identity because why? It's a plus b whole square. Let me write it properly here. So that is why we have to use the identity. There is no way you can just square them all. Like, don't think, oh, I will just x square, it's x power 4, 8 squared. No, you have to use the identity. It will be x squared the whole square, because we already have square. A is x squared whole square times 2 times x squared multiplied with b is 8 plus 8 squared. And over here it's very simple. It's just distributive property. It will be 2x squared plus 16 minus 8. Now here it is x to the power 4 plus 2. 2 times 8 is 16. X squared plus 64 plus 2x squared plus 16 minus 8. So add them all up. It will be 16 plus 8 only. That's going to be 72. So x power 4 plus 16 plus 2 is 18x squared plus 72. This is the final answer. And I can see that Tobias did it correctly. Now, what mistake did he do? Explain your reasoning is there. Um, okay, he has done this. Ah, you can see here, this 2x, we have to substitute. See, I did over here, instead of x square, I put this as the whole square. Then 2 of this x, it doesn't remain x. You have to substitute this x square plus 8, right? That is the mistake. Okay. See, you can directly look into both. It was the first step only. What if it was a long problem? It's somewhere down. So it's better you solve it by yourself and then you can easily tell which is correct. I hope that one is also clear. And Tobias is correct. The Chris, what he did was he did not substitute g of x for every value of x in the function f of x. That's the thing. We have another interesting problem. Here we have to multiply, not compose. See, this is whole, not sorry, it's a point, right? Not a whole. Whole is composition, point is multiplication. Now here g of x is multiplied to, both of them are multiplied. So what's the answer? It is basically x to the power 6 multiplied by root of x to the power 6, right? It's x to the power 6 only, square root cancels, right? This becomes whole. Now, otherwise, if you're getting confused like this, you can just write what does the square root means. It is power 3, and this is how much? Again, we have 6 by 3. So, sorry, this is 2, not cube root, it's square root, right? It's always 2, 2. Okay, this is 2 divided by 2 divided by 2. So you can solve them up. 6 plus 6 divided by 2, because the denominators are same, add the numerators. So you will have 12 divided by 2, and that is x to the power 6. That's it. Over here it is cube x to the power 3 square root of that. So it's gonna be like this. So you can just cancel it off. If you think practically, now I have x cube, I need to split it out into 2. So I can do this, right? So the same thing what has been done over here. So what we do is here x3 of half times x3 half. Whenever you have a square root, it's, if you have just like this is x half, power half. If you have cube root over here, then it will be 1 divided by 3. Whatever for the radical symbol, it will be divided. Now this is basically x power 3 only. Now I've just erased all this. I'll write the answers directly. F of x has been multiplied over here. It's cubed. Over here, what happens? It's 6. So now we need to find the domain. And we need to think whether it will satisfy the above conditions as well. Now here, what happens? X to the power 6, right? You don't need to solve these, to be very honest. This is not even required. I've just done it over here because they have told. I just realized the question is only to determine each domain, not to solve them, okay? The domain, what happens is, here let's first do g of x. Doesn't matter what, we have an even power. So imagine you have taken, say, value of -3. When you power it to the 6, I am not sure about the answer, it'll be more than 247, but the answer will be positive no matter what when it's an even power. If it's -3 the whole square, it's going to be an even power. It's going to be positive 9. 4, it's going to be positive 243. It will be positive, positive. Whenever there is even power, it's positive. But when there is odd power, say you have 2 to the power 1, -2 to the power 1. This is just -2, right? Say you have -2 to the power 3. It's going to be 3. This is okay. It's going to be 8, yes, but it'll be negative sign. Why? Because -2 times -2 times -2. This will be positive. 4 times -2 will be -8. So this is negative. Whenever you have odd powers, negative sign sustains or remains. So the first domain, since it's having even power, it's all real numbers. The domain is all real numbers, because even if it's a square root cannot have minus over here, right? Doesn't matter. Whichever minus or positive, because of this even power, it will only become positive. So here all real numbers are possible. Whereas, what about this? Here, no, we cannot take all real numbers, because if you take minus value for x, it will remain minus and becomes imaginary. So it should be only positive real numbers, okay, NOS numbers. So this is the answers. For the first one, it's all real numbers are the domain, and next one it is only imaginary, sorry, all only positive numbers. See, all real numbers means minus infinity to infinity. Positive numbers means anything greater than zero till positive infinity. That's the answers. So we are in the last problem here. We need to state whether the following statement always or never true. Justify your argument. The domain of two functions f of x and g of x are composed of g of f of x is restricted by the domain of g of x. Okay, I don't think so. See, we just now saw some problems, right? Over here, the domain sometimes is not restricted, sometimes it is. So it is, you know, doesn't. Okay, let me just take, because you need to take an example problem and solve. I'll just show it over here. See, sometimes it's true. It's not never. It can happen. Look over here. One domain was different. One domain was, all real numbers. One there was restriction. One there wasn't. So what it means is, now this is multiplication, but still, here when we compose as well, look at this here. See, when imagine you have taken a function f of x and g of x is root x, because root x are the only ones which will restrict, right? Now put it over here. Over here, instead, how we are composing? We are composing g of f of x. Now instead of x, what do you put? 4x. Over here you put. Now yes, the domain of g of x is what? Square root. This is restricting. Why? Because x cannot be any negative numbers. It should only be positive real numbers. Yes. But the same thing, imagine you had a square over here. X was positive power. Over here, if it was odd number, if it was x power 3 as well, you have issue. Why? Because square root of x power 3, x power 5, or any odd number, odd powers, the domain is restricted by this function square root. But same thing for even powers, it doesn't have any restriction. Over here, all real numbers, right? Why? Because it doesn't matter which, it will be a positive, so square root, it's fine. You will never have undefined answers. So in this case, the domain is not restricted when it's even power. So we can't tell it's always, it's only sometimes that happens. Okay, sometimes the square root will restrict it. And that's the end of this topic, another long one. I hope this is helpful. Please do try to analyze these problems thoroughly after watching the video, or during watching the video, solve them in writing. Please note down the steps, write it in steps, and be thorough with these problems.